Hello students, welcome to the third and last part of this video on the topic of stability of vehicle in curved paths. In the previous two parts, we have discussed about lateral sliding, lateral sliding velocity, that is V is equal to under root mu into GR, lateral sliding and impact and overturning of the vehicle. We have derived the formula for overturning velocity. V is equal to under root TGR upon 2h meter per second. So in the previous video, I have discussed that there is another method to discuss the concept of overturning, and that is by using the resultant, that is by calculating the resultant of the two forces CF, centrifugal force, and weight which is acting downward, weight of the vehicle. So the resultant of these two forces is represented by dashed line, which is R, and it is passing through the center of the outer wheels. So if the resultant is passing towards the left of your center of the outer wheel, then your vehicle will not overturn. But if this resultant is shifted a little towards the right of the center of the outer wheels, then your vehicle will definitely overturn. So let's say there is a angle which I representing with my cursor, that is this angle. For example, say this is theta, and it is the angle between the two forces, that is W weight and R resultant of the two forces. So this angle, suppose this angle is theta. So if this angle is theta, we can have a triangle here. We can have a right angle triangle here whose hypotenuse is this, and this vertical side is represented by this h height. For example, this height is h, and this is the base of the y is the base of the triangle, right angle triangle. So we can have this angle theta. Tan theta is equal to opposite side means y, opposite side y upon adjacent side means h. So tan theta will be y upon h, and y is half of t. This wheel track, y is half of t. So tan theta can be represented as half of t divided by h. So we have written the formula for tan theta. The angle theta can be determined from this equation. Tan theta is equal to half of t upon h. Or we can say that tan theta, we can also write this horizontal distance can be represented in terms of forces. This is acting centrifugal force acting towards the right, CF upon W. So tan theta can also be written as CF upon W, CF upon mg. So CF is written as mv square upon r, mv square upon r into is equal to tan theta into mg. We have put the value of centrifugal force mv square upon r here, and we have derived the formula for the overturning velocity. So overturning velocity can be written as v is equal to tan theta into mg under root. So we have two formulas for the overturning velocity. We can calculate the overturning velocity from any of these two formulas depending upon the parameters given in the question. So first one was, in the previous part, we have calculated overturning velocity TGR upon 2h under root, and in this part we have determined the value of overturning velocity. We have derived the formula for overturning velocity as tan theta into mg under root. So these are the two formulas. And tan theta, how will you calculate this tan theta? Tan theta can be calculated as t upon 2h, as we have derived in this part. Tan theta is equal to half of t upon h. So from these formulas you can solve the numericals depending based on these concepts. It is the topic of vehicle stability on a curved road. Hope you guys understand all the concepts. I recommend all of you guys to make notes of this topic because this is a very important topic for you. And thank you.